linear functions which maps from closed interval of -1 comma 1 to closed interval of 0 comma 2. Means what? In f of x, x belongs to, means domain -1 comma 1 and codomain or range y belongs to closed interval of 0 comma 2. Okay. Number of linear function means let us take y is equal to mx plus c. It is called the linear function, or you can take y is equal to ax plus b also. Okay, what is the question? Find first m values and c values. After that, according to number of values of m comma c, we can decide the number of linear functions. Okay, which maps closed interval of -1 comma 1 to closed interval of 0 comma 2. So these are the x values and these are the y values. You come here, I will explain one example before finding the values of m comma c. Here let us consider y is equal to 2x plus 1 straight line. You observe that it is in the form of y equal to mx plus c. Here slope is 2. So slope is equal to 2. 2 means it is positive. So therefore in this case m is positive. M is positive. Okay. Let us take one graph, simple graph. This is the x-axis and y-axis. I am taking first x equal to 0. So x equal to 0, then y is what? Y equal to 1. Okay. Take another value. X equal to 1. Then y is what? 2 into 1, 2. 2 plus 1, 3. Y value 3. Y value 3. So let us plot these points. X 0. Then y equal to 1. Just like that. So 0 comma 1. One point is there. Next 1 comma 3. X value 1. Y value suppose 3. Means what? It is increased from 1 to 3. So it will be 3. So this value is 3. That's why I am telling that if m positive, then it is increasing function. It is increasing function. Similarly, let us consider y equal to minus 2x plus 1. Let us draw the graph of this line by taking random values. Similarly, if x equal to 0, then y equals to 1. Okay, we can plot here x equal to 0, y equal to 1. Next, if x equal to 1, then y is equal to put x equal to 1. Minus 2 into 1. Minus 2 plus 1. So minus 1. So y equal to minus 1. Where is minus 1? Let it be here. Minus 1. So for x equal to 1, y value minus 1. Means what? From 1 to it is diminished or decreased by minus 1. So the graph will be like that. Means this graph is going on like that. This graph is going on like that. That's why it is increasing function. That's why it is a decreasing function. It is the complete explanation for increasing and decreasing of the function, which is of the form y equal to mx plus c. This is the best example. So the inference is y is equal to mx plus c is an increasing function if m positive. Next, y equal to is a decreasing function if m is less than 0. So therefore here x quotient m, if m is positive, then it is increasing function. If m is negative, it is a decreasing function. So therefore first case, let m positive. Therefore y equal to mx plus c is increasing function. You can ask me, sir, if y is increasing function, so what? How can we find m comma c? Actually, these values are given. This is x value. These are y values. Whenever it is increasing function, then definitely f of lower bound, it will taking as lower bound, and for upper bound 1, that is equal to upper, lower to lower, upper to upper, just like that. So therefore we are having two equations just like that. F of 1 equals to 2. So therefore f of minus 1, put x equal to minus 1. This is the value of x, it is the value of y. So therefore x equal to minus 1. So minus m plus c is equal to y value 0. Here put x equal to 1. So m plus c, that is equal to 2. Now we shall solve these two equations for m comma c. Therefore minus m plus c is equal to 0 plus m plus c is equal to 2. So on addition, m will be cancelled, then 2c is equal to 2. That implies c is equals to 1. Okay, we got it, c value. Therefore, and we can take any equation, m plus c is equal to 2. Then m equal to 2 minus c, that is equal to minus 1. So therefore c is equal to 1, m is equal to 1. Then the linear function, the linear function is y equal to mx plus c. This is one linear function. Next we are having, or we are raising the second case 2. Case 2. Actually this is case 1. Let it be case 1. Next case 2. Let m is negative. So already I said here, if m is negative, then this function is decreasing function. So therefore y equal to mx plus c is a decreasing function. So what decreasing means? Decreasing means opposite. For lower it is taking upper. For upper it is taking lower. So what does it mean? F of, that implies f of lower bound is equal to upper bound in y values, and f of upper means 1, that is equal to lower means 0. Lower equal to 0. So as usually by using these two equations we are getting m comma c. So therefore f of minus 1 comma 2 means put x equal to minus 1 and y is equal to 2. In this equation y equal to mx plus c. Y equal to mx plus c. So therefore m minus x means minus m plus c, that is equal to 2, and f of 1 m plus c is equal to 0. M plus c is equal to 0. So that implies once again x minus 1 minus m plus c equal to 2, minus m plus c. Okay, minus m plus c is equal to 2 and m plus c is equal to 0. So on adding we are getting 2c is equal to 2, then c is equal to 1. C is equal to 1. So c is equal to 1. Next we can take any equation. So c is equal to, but m plus c is equal to 0, then m equal to minus c, that is equal to minus 1. So therefore in decreasing case m value minus 1 and c value 1, thus the linear equation y equal to minus x plus 1. So therefore we are having two linear functions or equations, namely y equal to x plus 1, y equal to minus x plus 1. Thus we are having two linear functions, because in first case it is increasing and in second case it is decreasing. So this is the standard procedure. Let us revise the trigonometrical identities, namely number 1, sin square theta plus cos square theta that is equal to 1. What about theta? Theta is any real number. It is true for all theta that belongs to capital R. Real number means you can write root 2, minus root 2 or pi by 2, etc., or 0, like that. So you can put any value instead of theta. But here theta, it will be theta. Both will be same. In that case only sin square theta plus cos square theta is equal to 1. Remember, sin square theta plus cos square alpha not at all equals to 1 because theta not equals to alpha. Both are different. If you are putting 30 degrees, you will put here 30 degrees. If you are putting 45 degrees, you must put here 45 degrees. It is called theta, theta. Therefore, sin square theta plus cos square theta is equal to 1. Okay, this is the trigonometrical identity. Identity means actual definition. If the given statement is true for every real number, then it is called identity property. Okay, next let us consider another 1 plus tan square theta that is equal to secant square theta. 1 plus tan square theta is equal to theta, secant square theta. Actually, it is not identity property. Just they are saying, so many authors are saying it is also called as identity property because we are having number 1. No, it is not identical property. Let us see. So that implies 1 plus tan square theta means what? Or first we shall write like that. So secant square, it should be secant square minus tan square theta that is equals to 1. What I am telling that it is not identical property. Why? Because it is not true for all theta belongs to capital R. Why? Next question. Why? So secant square means that it should be 1 by cos square theta. Next, tan square theta means that sin square theta divided by cos square theta. So on taking LCM, the denominator will become cos square theta. Next, 1 minus sin square theta. You can say bluntly, sir, 1 minus sin square theta is equal to cos square theta. So numerator contains cos square theta, denominator contains cos square theta. Then we can cancel easily and we are getting 1. But in mathematics, till today, nobody can found that what is the value of 0 by 0. Remember. Okay? Mind it, 0 by 0 is not equal to 1. It is an indeterminate form. Okay, sir. Why you did introduce this indeterminate form means I am asking one question. If theta is equal to 90 degrees, then sin 90 is equal to 1, 1 square equal to 1, 1 minus 1 equal to 0 divided by, if theta equal to 90 degrees, then cos 90 is equal to 0, 0 square is equal to 0. Therefore, can we write on cancelling 0, 0, it is equal to 1? No, it is wrong. Therefore, this statement is not true for multiples of, odd multiples. Already we did know the general solution for cos theta is equal to 0 is that theta is equal to odd multiples of pi by 2 for all n belongs to z. So therefore, what I am telling that it is not equal to 1 for all theta that is belongs to odd multiples of pi by 2 for all n belongs to z. Therefore you come here. Therefore, secant square theta minus tan square theta will be equal to 1 for all theta belongs to any real number except theta. Theta is equal to odd multiples of pi by 2, odd multiples of pi by 2, whereas n belongs to z. Therefore in this class I proved that 1 plus tan square theta is equal to secant square theta. Only one formula, ordinary formula. It is not identical formula. Identical formula means it should be true for all theta belongs to capital R. Then only it is called as identical formula. Mind it. So therefore, this equation is true for all theta belongs to any real number except odd multiples of pi by 2. Okay? So therefore, let it be. This is one discussion. It is useful for this question. Okay. Some students are doing like that, or saying like that, sir, f of x is equals to, actually it is in the form of sin square theta plus cos square theta. Sir, it is 1 for all theta x belongs to capital R, and secant square x means g of x. We studied in 11th standard trigonometry. 1 plus tan square theta equal to secant square theta. Thus secant square theta minus tan square theta equal to 1. So therefore, it is also 1 for all x belongs to capital R. Some students will say like that. Hence, sir, for all x belongs to capital R. So therefore, second option is right, sir. It is the wrong step. You must know that in your life, instead of what to do, what not to do, first you find like that. So therefore, this is the wrong way. Which one is the right way? This is the right way. So what I am telling that f of x is equal to 1. Of course, it is for all x belongs to capital R. For all x belongs to capital R. f of x equal to 1 for all x belongs to capital R. G of x is also equal to 1, but for all x belongs to any real number except odd multiples. X belongs to, or x equal to odd multiples of pi by 2. So for all n belongs to z. For all n belongs to z. Okay, for two functions we have to find the common domain. What is the common domain? R means every number. Next, R minus odd multiples of 5 by 2. So therefore, the common domain is capital R means x belongs to capital R minus x, such that x equal to n plus 1 into pi by 2 for all n belongs to z. Thus, third option is right, but not second option. So, dear students, you must know that you must read carefully what is identical property and which one is not identical property. So here we are having another extra condition. Therefore, this is not identical property. Remember. F from capital R to capital R defined by f of x equal to x divided by x square plus 1. X belongs to capital R. We have to verify for one function and onto function. Here f of x equal to x divided by x square plus 1. Here I am using new approaching. What is f of 1 by x? F of 1 by x equal to, so instead of x write 1 by x, and remaining signs, powers, coefficients, everything is same. So instead of x, it is 1 by x divided by, it is 1 by x means x square plus 1. So that equal to 1 by x divided by 1 plus x square whole by x square. So on simplification, 1 by x into x square by 1 plus x square. So on cancelling x, it remains x divided by 1 plus x square. So observe, it is again f of x. So therefore, here what is happening? F of x equal to 1 by f of 1 by x. Of course, x not equal to 0. I am telling that for all x belongs to real number except 0, f of x equal to 1 by f of x, f of 1 by x, f of x equals to f of 1 by x. Since it is in denominator, for no loss of generality, I wrote minus 0 singleton set. Okay. So, means what? F of 2 is equal to f of 1 by 2. F of 3 is equal to f of 1 by 3. Just like that. Infinite numbers we can write like that. Means what? Means what? F of 2 means this is the domain. This is the domain. This is codomain. This is codomain. It is also capital R. So, the point or element 2 is there and 1 by 2 is also there. By putting x equal to 2 by 2 square 4 plus 1 5, 2 by 5. In R 2 by 5 is there. 1 by 2 is mapped with 2 by 5 and 2 is also mapped with 2 by 5. Like that. Similarly, 3 1 by 3. 3 1 by 3. Both are mapped with the same element in codomain just like that. Therefore, thus f of x is not 1 1 function. Means what? Definitely it is not first option. Means maybe fourth option. So definitely third option is not correct option, because if f is 1 1 and onto function, then only it is said to be a bijective function. Therefore, when it is not onto function, bluntly we can say that it is not bijective function. Therefore, first option, third option will be wrong. Next, we are going to verifying for onto function. So, I will follow the as usual procedure. So, for onto function, test for onto function. First, let y is equal to f of x, then y is equal to x divided by x square plus 1. So on cross multiplication, x square plus 1 into y is equal to x. That implies x square into y plus y minus x equal to 0. So that implies y into x square plus minus 1 into x plus 1 into y means y. That is equal to 0. So clearly it is a quadratic equation in terms of x. Similarly, it is small a, it is small b, it will be small c. So here x is equal to, so y into x square plus minus 1 into x plus y is equal to 0, comma here x, he said x belongs to capital R. X belongs to capital R. So we did know the very familiar formula, delta greater than or equal to 0. X means what? Root of this equation. Roots are real numbers. Therefore, definitely discriminant greater than or equal to 0. Discriminant means what? B square minus 4AC. 4AC greater than or equal to 0. So B square 1 minus 4AC means y. It is greater than or equal to 0. So therefore, it will be 1 minus 4 y square greater than or equal to 0. So 1 by 4 minus y square greater than or equal to 0. You come here. So that implies y square minus 1 by 4 means 1 by 2 whole square less than or equal to 0. So it will be y plus 1 by 2 into y minus 1 by 2 less than or equal to 0. So y minus 1 by 2 into y minus plus 1 by 2 less than or equal to 0. Look at the board. So that implies y that belongs to closed interval of minus 2 comma plus 2. Y is what in this topic? Y means range. Y means range. Therefore range. Y means range. Range is equal to closed interval of minus 1 by 2 comma plus 1 by 2. But it is a subset of codomain. Codomain is what? You come here. Codomain capital R here. Therefore range. Okay. Is it visible? Therefore range is equal to closed interval of minus 1 by 2 comma plus 1 by 2. You come here. Here, this is the codomain. This is the domain. So clearly, this interval is a subset of codomain R. Codomain capital R means what? It is subset of capital R. Capital R means it is a codomain. Therefore, range is a subset of codomain. What is the actual definition of onto function? Onto function means range is equal to codomain, or f of A is equal to capital B. Then f from A to B is called onto function. Onto function. So therefore, when it is subset, mind it, if is equal to then onto, but it is not is equal to. Therefore f is not onto function. So therefore f is neither one function nor onto function. This is the complete explanation for fourth option. Neither one function nor onto function. Wait 1 minute. Okay, this is the complete solution, complete explanation for this question. Okay, 1 minute. Let y is equal to 1. Y means what? F of x. X divided by x square plus 1 equal to 1. Means what? X square plus 1 equal to x. So x square minus x plus 1 equal to 0. It is the quadratic equation. So what is delta here? B square minus 4ac. That is equal to 1 minus 4. That is equal to minus 3. Of course, less than 0. Means this equation do not have the real roots. The real root. So what? Means this is domain, this is codomain. What does it mean? What does it mean of this proof? Domain means it is the values of x, it is the values of y. Means if y is equal to 1, there is no pre-image. Therefore, it is into function, not onto function. This is the example. So, or another method to say that it is not onto function. This is the complete proof to say that f is not onto function. This is the different approach for showing it is f is not a one function.